Hi, my name is Willi Eggeling and I'm software developer at InnoSoft AG Marburg. Today I want to talk to you about web security and why it is important. The variety of devices we call a computer steadily increases. This does not only include computers in a traditional way, like mobile computers, desktops and smartphones, but also cars, TVs and also refrigerators. All these devices have something in common. They are web capable, they have a web browser. This is why the web evolved as the largest platform. This has two consequences. First, the web gets more and more powerful, more and more feature-rich. Second, it gets more and more attractive to possible attackers. Many people don't take web security as serious as it should be. They say something like, well, I can inject some JavaScript at this website, but who cares? Well, I'm going to show you why you should care. This talk is separated into two parts. First, I want to show you what is even possible without exploiting a single security issue. For the second part, I want to show you what we can do by using a security issue to take over a whole current computer system. The screen is divided into two parts. The victim, which we are going to attack, is on the right side. It's a current up-to-date Windows 7 virtual machine running Internet Explorer version 9 and a portable Firefox version. On the left side is the Linux computer I'm going to use to attack. We are going to attack a victim by running malicious JavaScript code on its browser. But how does the code get to the victim? We make use of a security issue called cross-site scripting, that is about injecting malicious code into a trusted environment, a web application in this case. I'm using DVWH, the damn vulnerable web application, for demonstration purposes here. Let's log in and see what cross-site scripting looks like. This page acts as a guestbook just as you find it all across the internet. I can leave a message that can be seen by all other visitors. But I can not only insert text messages here. Let's try to enter some JavaScript. As you see, the JavaScript is not displayed as text but gets executed by the browser. We just made use of a cross-site scripting issue by the web application. We inserted JavaScript into a trusted site that gets executed by each visitor of the page. Okay, let's reset the database and start over. We create a new message, but this time we do not enter the JavaScript code directly, but refer to it on another server. You can see only the text that we entered, but not the code itself. And this is how it looks to victims that visit the page. Let's switch to the victim. We use a regular Internet Explorer 9 that was not tampered in any way. We go to the web application just like we did on the attacker side and open the vulnerable page. That's it. We hacked the victim, even though we cannot see any strange behavior on the victim side. Let's switch to the attacker. We open the web interface of Beef, the attacking framework we use. Every browser that visits the malicious page is listed here and stored even after it gets offline. We wait for a victim to appear on the list. And there it is. We can see a new Internet Explorer running on Windows in a virtual machine. We click on the new browser and get basic information about it. If we scroll down, we can see that ActiveX is enabled. We make use of this later. We can not only retrieve information about our victim, but can also execute commands on it. We open the list of predefined commands and create an alert dialog. That is what we did in the first cross-site scripting test. We enter the text, execute the command, and our victim displays the alert dialog. Okay, Let's try something less static. Consider the guest book to be a form containing sensitive information, like a login dialog or text form. We enter some text on the victim side and retrieve it using another command. We can also retrieve the cookie information of the current domain. Let's have a look what cookies are stored on the browser. Here we go, we just retrieved the session ID. As ActiveX is enabled and the current site is in the trusted sites, we can also retrieve registry keys. Let's do it. We use the pre-selected keys, execute the command, and have a look at the result. The client does not see any information about this. ActiveX can not only be used to retrieve information about the client, but also directly execute client-side commands. Let's start an application. As you see, we just started the Windows calculator. Okay, enough hacking the Internet Explorer. Let's switch to a portable Firefox version. Currently, our attack only works as long as the user stays on the infected page. That is not very useful and not a realistic scenario at all. We use the man in the browser attack, or command, to modify the page so the browser stays connected as long as we don't leave the current domain. Let's run the command. Okay, let's navigate away on the victim and create another alert dialog to test if we are still connected. And here we go. Besides direct attacks and manipulation, social engineering is an important attack vector as well. We lead the user to give us the desired information by choice under false pretenses. Let's start with a fake notification bar, something you may have already seen. If the user clicks on the fake bar, a custom download is triggered. Another sneaky approach is a fake flash update, because every user is taught to update each time it asks for it. Just like the fake notification bar, a custom download is triggered when the user downloads the fake update. Okay, let's try something different. We go back to the victim, log out, and log in as a different user. Now, back on attacker side, we right-click on the victim and choose Use as Proxy. We switch to the web application and see that we are logged in as admin. Now we go to the proxy settings and set up a local proxy. Refresh the page, and we are logged on as Gordon B, the user of the victim. So what did we do? We used the victim browser as a proxy server. By doing this, we do not only browse using the victim's IP address, but also share all its current sessions. And remember, we did not exploit a single security issue at the victim's side, so this can happen to you as well, no matter what browser or platform you use. Okay. Let's go to the second part of the presentation and try to take over the victim completely by using a security issue in the Firefox browser. We use a framework called Metasploit, run a local server, and visit a special website on the victim side. The fact that we use Firefox here does not mean that this won't work with Chrome or Internet Explorer as well, or any mobile platform. Let's have a look what's possible now. First, let's have a look at the victim's system information. Okay, let's see what processes are currently running. We initially infected the Firefox browser, so we are limited to it. If the user closes the Firefox, our connection is gone. So let's migrate to another process. Let's have a look at the process list and, well, we choose explorer.exe, a process that runs all the time the connection. Let's have a look at the explorer.exe would work great for us as it stays alive as long as the user is logged into the computer. So let's migrate to that process. The Firefox will crash, but we don't care. Okay, our migration completed successfully. We are now a part of explorer.exe and are not dependent of any other running process. Let's annoy the victim by disabling the mouse. As you can see, clicking the mouse doesn't work anymore. We, as the attacker, would really like to see the screen of the victim, so let's run a VNC session. Okay, let's start a command prompt. And run Notepad. We can see what happens live on the right side in the VNC session. So we could do everything that is possible with the user's privileges on the current computer. We really took over the complete system. That brings me to the end of my presentation. I hope I could raise awareness of how important web security is. Thank you for your attention and goodbye.